This how-to video looks at titration curves and types of titration curves you get with different concentrations of acid and base. And on the screen I've pasted some information to help this narrative. So if we look over here to start with at the strong acid, strong base titration curve, you'll see a typical plot. In this case, because it's a strong acid, the line begins down around pH 1, and because it's a strong base, it ends up around 13. But it's this section in the middle which is important, and as you may recollect, this is called the equivalence point. This is the point at when neutralization occurs. And it's very important that when we draw one of these graphs, or sketch one of these graphs in an exam question, that first of all we put the scale on, an axis scale here, and preferably an axis scale here too if possible, and I'll talk about that briefly later. But it's very important that we get these ranges correct. So I just want to add a little bit of an annotation to this graph to start with. Now what I've done is I've just highlighted where the vertical section, the equivalence point section, actually is on the graph. And you need to note this, that if it's a strong acid and a strong base, the equivalence point starts roughly around pH 4, just below pH 4, and it ends just above pH 10. 10.5, and this section is quite a long section. Now the reason I say that is if you don't get this equivalent point in the right place or the right size, you'll get the question marked wrong or down marked. So let's quickly move on then to the second graph, which is the strong acid and weak base, and just have a look at the comparison. So I hope you can see the difference. Again, I've put the annotation on. Because it's a strong acid, again the equivalence point starts, this vertical section starts again around about pH 4, just below pH 4. But because we're going to a weak base in this case, the equivalence point finishes at about pH 7.5, certainly not above 8, and certainly not below 7, but about 7.5. Now look at the difference between this one and this one. So again, this range, this equivalence point range, is significantly different to this equivalent points range. And this is the sort of thing that you'd be expected to put onto an exam, and that's why this scale is crucial. Okay, so let's look at a weak acid and strong base now, and I'll do exactly the same. Now I think you can see the difference. This time we're starting with the weak acid, so we're starting around pH 4, 3, 4, and because we're going to a strong base, we're finishing around about pH 13, like in our first graph. But look where the equivalence point range is now. It finishes around about pH 10, 10.5, but this time it starts at around about pH 6.5, not at 7, below 7, but pH 6.5, pH 6.25 is the range we're looking for. So just by inspection on these three graphs, you can see where these different ranges need to be, and where you need to be very careful when you're drawing these types of sketches or diagrams. I haven't put on the screen a weak acid and a weak base, so let's just quickly see what this might be like by adjusting this diagram. So here I've added a line to represent the weak base. We're starting with our weak acid, and look at the size of our equivalence point now. and look at the region it's in. This time, again, it starts at about 6.5, but this time it ends at about 7.5. So we have a very, very small section which equates to the equivalence point, a very, very small vertical section. Now I hope that helps. It is crucial that when you draw these diagrams that, and I repeat something which I've said earlier in this video, that you get the scale on, and it's equally important that you get these equivalent point ranges in roughly the areas which I've indicated on this video and in these diagrams. One last thing to mention then, I did mention concentration to start with. If we were starting with a strong acid such as hydrochloric acid and its concentration was 0.1 mole per decimeter cubed, and we started with 25 centimeters cubed of it, and we added a strong base, in this case 0.1 mole decimeter cubed of the base, and we'll call this sodium hydroxide, they would expect you in your drawing of this to appreciate that, well, if it's 0.1 mole per decimeter cubed hydrochloric acid, then an equal volume, 25 centimeters cubed, of 0.1 mole sodium hydroxide, a strong base, will neutralise it. So they would expect this vertical line to be on the 25 centimeter cube mark. So that's an additional thing to look out for. It's often asked for in a question, how much did you need to add to neutralise the acid or the base entirely? And if you were drawing a curve, you'd definitely need to be cognizant of this scale of how much you are adding to get to affect that neutralisation. I hope that helps. Thanks.